Hi there. In this video, let's try to learn how to obtain transistor characteristic curves by doing simulation. Let me show you the background a bit. Now, when we have a bipolar junction transistor, usually we obtain three different characteristic curves. One is called input characteristic curve, then current transfer characteristic curve, and output characteristic curve. Now, the input characteristic curve is obtained by considering input, that is IB current and VBE voltage. VBE junction, this you can in fact consider there is a diode available here. So it more or less looks like a VI characteristic curve of junction diode. So the axis are BE and IB. So we would obtain something like that. And also by extrapolating this one, you can even find the barrier potential. This should be somewhere around 0.7 volts. Then the transfer characteristic. So in this case, we assume that VCE is a constant. So when we keep VCE constant, we obtain current transfer characteristics. So that is where the real function of the transistor exists. When transistor operate in active mode, we used to write IC equals beta IB, and beta is the current gain. So that is where the active mode is working. So when it comes to current transfer function, we plot IB current and IC current. And you can see here this position, we call it cutoff mode, because IB equals IC equals 0. Then you can see this section, it's a linear region. So we call transistor operates in active mode in this region. And then we have this region, even though we increase IB current. So we increase the input current, but output does not increase. So that region we call saturation region. Saturation region, active or linear region, and cutoff region. When it comes to output characteristics, we are looking at the output. So here the important parameters are IC current and VCE voltage. So this is output characteristic curve. And you can see that this curve is drawn for three different IB currents. So in this case, so if you want to obtain one of these curves, you need to fix IB current. For a certain IB current, you obtain one of the curves. So here we have obtained three of these curves for three different IB values. Let's move to OCAD and see how we can do this simulation and how to obtain these curves by doing a simulation. Here I have already started the PSpice project in OCAD. So this is my CaptureSys window, and I'm going to put a few components here. Since we have finished drawing our schematic diagram, so this diagram we can use to simulate or obtain all three characteristic curves. So input characteristic curve is basically drawn in between considering this VBE voltage and IB current. So in order to obtain this one, what we could do is we can fix our input voltage to some value, supply voltage some values, and we can vary this battery voltage from some value to another value in order to obtain this one. So this one you can easily do with the DC sweep. So let me start developing a simulation profile. In this project, what I need to do is to do a DC sweep. So I need to sweep my input voltage from one value to another value. So then the source that I need to sweep is V1. So I'll put source name as V1, and start value I'll start with 0 volts, and end value I will go up to 1 volt, and increment I'll put little bit of small increment 001 volts. And let's do the simulation. So I'm going to run the simulation. So once I finish the simulation, I don't get anything from the Spice window. So I need to add traces. First thing is I will add the trace that I can use this button to add trace. So my y-axis, what I want is IB current. So I will pick this particular one. This Q1 is the transistor, and this is the current through base. And now what we have is y-axis is IB current, but x-axis is V voltage of V1. So V1 is the source. But what we need is the potential drop across this BE junction. So that we need to find it. So therefore we need to change variable in x-axis. So let's try to change the variable. I go to plot axis settings, and then I'll change axis variable. So it's x-axis variable I'm going to change. So I need VBE. So I'll remove the rest of the things. So these are some of the filters so that I will only see available voltages now. So I need VBE voltage. So that is VB voltage. So I'll delete this one. So what I need is VB voltage minus VE voltage. That is what we call VBE. Right. Now we are in good shape. You can see this is the input characteristic curve. So there are a few things that you can do with this kind of curve. If you want to do a little bit of decoration, you can do it. So here I have already put data points. So data points are already there. So if I remove data points, you will see it's a software generated line. But if you want to see the data points that we use to do the simulation, you need to put this mark data point. So now since our increment is very small, you will see there are a large number of data points available. And also if you want to little bit of make it nice, so maybe I'll make it a little bit thick line now. Yeah, it's kind of good now, I guess. So you can see this is our input characteristic curve. When it comes to obtaining current transfer characteristics, we plot IB and IC. Now, when we look at the simulation output, we can see that when we change VBE voltage from 400 to 700, we can obtain IB. During this time, IB is almost 0 and IB is increasing. So therefore, we can think that for the transfer characteristics, we can sweep our voltage source V1 from, let's say, 0.4 volts to 0.8 volt. We'll see, and if that's issue, we'll change it. So in order to obtain transfer characteristic curve, so I will fix VBE voltage to some reasonable value, let's say 12 volts. And then we need to sweep V1. So when we sweep it, basically we sweep the current from here. So as we discussed earlier, we will sweep V1 source from 0.4 volts to 0.8 volts. So I'll go and edit DC sweep settings. So it's V1 source. Instead of 0, I'll go from 0.4 to 0.8. And I'll keep the same increment. Let me add a current probe also here, so then it is easier. I'll take current probe and tag it to the transistor collector. So that collector current will be plotted against V1 voltage source. So I'll run the simulation and then I can see output from the graph window. So this is what I see, but you see the x-axis is V1 voltage source. That is not what we want. X-axis has to be changed to IC. So I'll go to plot, axis settings, and change x-axis variable. So I'll change that to IB. Right. So now we are good to go. So x-axis is IB and y-axis IC. You can see that it starts from 0 IC current, IB current 0, cutoff region, and this is active region. And then you go to the saturation region. Now let's try to obtain the output characteristic curve. So in this curve, we need to have VCE, that is this voltage, and current to the collector IC. So in this case, we need to sweep two variables, V2 and V1. So we change V1 while measuring IC, V2 while measuring IC, as well as we need to take the measurement, repeat the measurement for several IB current. So therefore that feature is available here as a secondary sweep. So that's basically we do sweep within a sweep, that is called nested sweep. So let's go and edit the simulation profile for this to match this scenario. So the V2 variable, that is the voltage source attached to the CE terminals, so that we need to change probably from 0 volts to 6 volts in 0.5 steps. And then we have secondary sweep, so we can enable secondary sweep, and the sweep source is V1. And as you remember, V1, we don't need to start from 0, because from 0 we don't have anything, but maybe after 0.5 volt it starts increasing and we can go up to 0.7. So they have we go to the saturation level. So the increment should be little bit small in this case, because when we have a non-linear behavior, so the output increment really drastical. So it's very sensitive for a small change in this one, so that we can obtain several curves. Then we'll run the simulation, and you might notice that I haven't put any of the probes here, so that I will receive a blank graph like this. So then what I will do is, I will first of all I will change x-axis. I'll go to plot, axis settings, variable. So what I want is a voltage, so I will remove the rest of things here. Then I need VCE, so it's VC voltage minus VE voltage, that is VCE. So now x-axis is now set. Then I need to add a trace for the y-axis, so I'll go to add trace, and here I need IC. So if I want, I can use the filters so that it is clear. So these are the available measurements for the currents. So I pick IC. Okay, so we have our required curve. Hope it is clear now. So we managed to get input characteristic curve, current transfer characteristic curve, as well as output characteristic curve. So a few things that we did for the input characteristic curve. So we change VBE. In order to change it, we change the voltage source nearby VBE, that is V1. And then when we plot it, we change x-axis to VBE. For the transfer characteristic, we need IB as the x-axis. So we change the input, but VCE we fix to a certain voltage, so that we can obtain this one easily. Then for the output characteristic, it's a little bit complicated. So x-axis is VCE, so x-axis change is required, and y-axis is IC. It is not that difficult, but we need to obtain different curves. So here we have 3 curves. So if you want to obtain 3 curves, we need to supply 3 different current values. So therefore, we need to have 2 sweeps, primary sweep and secondary sweep. So we sweep both sources. So hope it is clear. So if you have any issues, please put a comment there. So I'll try to answer. Thank you very much and see you in next video.